Alright, 7 o'clock on the dot. Starting now. Well, I don't really need to send the link because it's a public stream. We're actually doing this class publicly, so my bad. Did I turn on the public stream? Let's try it. The changes saved, and we should be public right now on this stream. So I don't really need to share the link to the group, but I will just in case. So we're doing a public class. Lubes are live there now, eh? Let's see if this is going live. I need to check because I'm not seeing people popping. It's supposed to be a public. Let's see if it's public. So if you're inside, just shout out something there. Share. Copy link. Something is suspicious. Boom. And boom. Good night, good night. Alright, so yes, it is public, so we're inside. So you all got that notification on YouTube, right? But I did a little mess up here in that I went private firstly and then it popped back. Is it? I'm only seeing class people here. Let's check. If you're seeing the stream properly, just write wise in the chat. Wise in the chat if you're seeing the stream properly. Just supposed to be. Alright, YouTube doing the thing. YouTube doing the thing. What else? Lastly, public. Alright, we inside. So today's class is on functions and relations. Right. Good night, everyone. Good night, Selena, Christian, Daryl, Lishra, Keziah. Bite me again. 316, whatever that means. IBTU, not toxic. Tonight's class is on functions and relations. We're starting off brand new on this topic. This is the 26th class. We're just happening to have this class on a public setting. So those who, if you have an exam tomorrow and you have functions and relations, again, a nice class here to fall into. It's going to be for 2 hours from 7 to 9. This is when our maths class is every night. So you're getting to join in with us here. Before we start, we're starting with a quote. Our quote for this week is from a guy named Paul, and it says, "Let us not become weary in doing good, for at the proper time we will reap a harvest if we do not give up." Coming down to the end of the year here is be one of the toughest times to study. Graphs, we're coming down to graphs in a bit, Christian. I had maths today. Pressure. Good night all. Good night all. Right, so one of the things they do in secondary school is give a really hard exam. I know a lot of schools do that. Especially if you're in Form 5 this term, you want to give the hardest exam ever. Just to let the Form 5s fail, so they'll know that you want to give them a CXE exam this round. So they'll know that don't play around with the exams, brethren and sisters. Yeah, so coming down to the end of the year, problems to keep that momentum. You're seeing Christmas, it'll be hard to get in that study, that time, that energy, that vibe. But all those who still keeping up and keeping strong, in May, in January, when there's a season, because you know life is seasons. Right now is the season of that hard times to study, that hard time to focus in class. When it's time for the season to reap, your math teacher preaching here. When it's time for the season to reap in May and January, what you planted way back in December will be reaped. Is reaped a word? Will be reaped. Will be reaped. So it's very important to put in the work and do not become weary. Do not become weary. We're doing this. We're doing this thing. Alright, so relations and functions. Relations. They normally start off with relations. Relations normally comes in multiple choice. But we'll do everything because this class we're doing everything, right? The entire syllabus. So relations. Another word for relation is like mapping. And there are three things that make something a relation. You must have two sets. So there's two sets. By the two sets, I mean the input and output. So you must have two sets, input and output. You must have what you will call like a rule. I don't want to say a function because not all relations are functions. So you use the word rule. So you must have something that connects in them. And the third thing, what is the third thing, boy? Given codomain and domain. What do you think is the third thing? Three conditions to satisfy a relation. What do you think is the third condition we must have? I can't remember. So far only a normal class here, Jordan. Now it has some people from the outside. But what happened is because I went private first and then I remember I changed it to public video, no notifications were sent out by YouTube. So it's those who online on YouTube right now and see at the top that I'm live getting to see this video. Those who you wouldn't get a notification on your phone just so. Anybody here came with a notification? But I feel as the live carries on, new batches of notification will start to trickle out. Anyhow, so we're trying to figure out the third thing that will make a relation. The third thing is, we'll call it like a direction for the rule. A directional property for the rule. So, three things that make a relation. All right, let's do an example. Let's say I had 1, 2, 3, and over here I had whatever by 2, 4, 6. Brilliant. Can't get better than that. And now I have these arrows going like this. This is already a relation here. We already established a relationship here. Well, the arrow, very good, Giovanni, an arrow, which is the direction. Hi from the US, love your channel, by the way. Blessings, Kareem. So, we have the three things. We have two sets. We have the input, and we normally use capital X. We have the output, we normally use capital Y when you draw the relations diagram. We have the rule. There's something taking place here. What is the rule? What is the rule? What do y'all think is the rule here? Rule. What's the rule? What is the rule that is occurring here? This is a one-to-one relation. Coming to that, we're going to go through the entire of the basic part of functions. Tonight, we're going to do composite functions, inverse functions, all of that. So we have two sets. We have a rule. What's the rule that's happening here? And clearly you all can see a direction. So we have a direction property taking place here. In terms of the arrow, we have this set is going to that set via the rule. So left, right. The rule, nobody can say the rule here. A one-to-one, yes, it's one-to-one. Nobody can say the rule so far. So maybe somebody will say just now, but the rule here is clearly, we see now you have a times 2. Let me just say times 2, right? Because it went from 1 to 2, 2 to 4, 3 to 6. So the rule is multiply the input by 2. And as I say input, there are other words you could use to talk about it. We could, the capital X, we could call that the domain. We can call that the input. The capital Y, what you call that, solely, boy? We could call that the codomain, right? We could technically, in this case, it's the range, but not all the time it's gonna be the range. I never really see CXC bring too much discrimination between the codomain and range, but for those who do pure maths, you'll know this is very important to know the difference between the codomain and the range. I'll talk about it for a tiny little bit in this class. We could call this the output, right? Or the images, or one value, we can call it the image. All right, so that's enough. Let's move on to this term. You may see this term popping up in your class, in your exam. What is an ordered pair? What is an ordered pair? Yeah. What is an ordered pair? If I have like 1, 2, 3 again, and instead I have 3, 6, 9. Let's not put 3, 6, 9. Let's put 4 dash 12. Yeah, boy, I feel like I'm being so clever here right now. Is it a relation? I don't understand the question. What do you mean, is it a relation? Yes, this is a relation. We have x, y here. Oh, ordered pair is an ordered pair relation. Yes, but what is the ordered pair itself? Like in this setting here, what is the ordered pair? Can you give me? There are 2 ordered pairs displayed here. The ordered pair is, we need to identify them like this: the input value and the image. We could separate them by a comma. So the ordered pair is 1, 4. Now I see somebody pelt out 8. Yes, 8 is gonna slip in here, obviously, because we could figure out the rule. What's the rule? The rule is that we are multiplying by 4. Now, in CXC, the rule not going to come that easy. The rule not going to come that easy. I'll give you a next one and see if you all can spot the rule. So 2, 8, that's another ordered pair. Boom. Here's our next ordered pair. 3, what's it? 12? 3, 12. 3, 12. So these are the ordered pairs here. So let's see if we can spot another rule. I'll make a little more complex one. Let's see if you can get this one. Let's see if you can get some Y's in the chat here. So I have, boom, capital X, and boom, capital Y. And I'm going to make the input, let's say 1, 2, 3. 1, 2, 3. So the same thing we do all the time. And I'm going to make the output, I'm not going to make the output the same thing we do all the time. I want to make the output, humbly. I will say 3, 5, 7. What is the rule here? Anybody in the chat? All 46 of you? Yes, we can say that, Giovanni. We can say that. Yeah, we can say that like just now. We can say that Y here, the Y values, another thing we can use for this. This is our Y value on the Cartesian plane, and this is our X values. Y values, X values. Another thing we can say here is Y is equal to 4X. Y is equal to 4 times X, right? Okay, but what's the rule in this one? What's the rule? Yes, it is a function, but what's the rule? What's the function here? What's happening to the input? Anybody? In the meanwhile, let me see some comments here. Left to right, Giovanni range. Giovanni. Addition going up 1. No. Adding 2, adding 2. That's not a rule. Now I know what you all mean by adding 2 in that you see, and this is add 2, add 2. But that is not the rule. The rule must connect not these. The rule must connect this to this. The rule must connect input values to output values. And 1 plus 2 is 3, yes. But 2 plus 2 is 4. And 3 plus 2 is 5. So you can't say add 2. Now, Rafael de Leon is on the right path here. He's saying that first we add 2, then we add 3, then we add 4. That's interesting. Increasing by 1 every time. Boom! Daniel hit them the rule day. Daniel Singh, well done. Adrian Mirage, well done. Y is equal to 2x plus 1. If you told me 2x plus 1, that's correct. Now you notice what happening there. So a hint for finding out the rule, if it pops in your multiple choice, or if it pops in your paper too, is that an investigation question, question 7, 8, 9, 10. Yeah. So question 7, you will need to identify rules per se. So from 3 to 5, you realize you go by 2, 5 to 7, you go by 2, you're going up consistently by 2. It means the x is going to get multiplied by 2. Now all you need to do is figure out what's the additional number to add or subtract to make the rule make sense. Let me show you what I mean. 1 by 2 is not 3. I need to add on 1. Okay, so I'll put add 1 here. Now let me just test it. Let me just test it with the next one. 2 by 2 is 4, add 1 is 5. Great. 3 by 2 is 6, add 1 is 7. That makes sense? 2x plus 1 is the rule. Let's try the next one. That was interesting. Let's say I had 2, 4, 6, and I'm doing 5 again, 11, and 17. That's interesting. Bam, 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 x, y. What is the rule? So all 45 of us here tonight, what's the rule? So really just blank me, yes? You multiply by 2, then add in 1. Oh, sorry. In maths, as a maths teacher, the first thing I see is equations. So when I see equations and numbers, them is look more attractive than actually whole sentences and things. It's easy, Raphael. Or, because this is a public video, press like on the video. And if you have time, you can share it with your friends. 3x minus 1, 3x minus 1, 3x minus 1. So well done, chat. The rule here is 3 by x, take away 1, because 2 by 3 is 6 and we minus 1. So, and how did we know it to multiply by 3? Because 5 to, hold on, 4 by 3 and 11 by 6 by 3. Oh, yeah, because when it's not going up, it's not going up by 3, it's actually going up by 6. But we know to multiply by 3 because this skipped 1. You understand? So this is going up by 2 and this is going up by 6. So it means the separation here is 6 divided by 2 is 3. I hope that makes sense. So this is 3 by the number, and all we need to do is figure out what to do. 3 by 2, and we need to take away the 1. So 3x take away 1 is the answer. So well done, BBIs and Geo. It increasing by 6, yes, but this one skipped 1. So like if there's a 3 inside here now, it will go 3 3s and 9, take away 1 is 8, and this is 5 to 3 is goes up by 3, and this goes up by 3. So it means you have to multiply by 3. You understand? Yes, sir. Injustice touchdown. Blessings, blessings. But ain't you do maths already? Don't you do maths already? How some people do maths already inside here. So okay, that's enough talk about relations. Let's talk about something else. Let's make the quick talk about codomain and range. This is 1, 2, 3. And if I said 1, 2, 3, 4, 5, 6, and I did this, we can see here that the rule is multiplied by 2 again, right? Straight up. Like the bread van passing. That's once I hear them horn, they know what's going on. I married for my son at Maximo Yacht yesterday. Blessings, bro. Thanks for the support. So the rule is multiplied by 2 here because the 1 went to 2, the 2 went to 4, the 3 went to 6. So the rule is multiplying by 2, right? Or you can write y is equal to 2x, which is that xy, right? But there's some points I could build off of this, you know? You notice everybody here get a chance, right? That's usually the case. You uploading this video after? Yeah, uploading it after. That's how I'm trying to be, yes? The bread. You're trying to be like Injustice Day? Injustice. Anyhow. 1, we multiply by 2 and we get 2, right? So this is 1, this is 1, this is 1. There's a little property between the range and the domain and the codomain. What's the difference between the range and the codomain? Meriting man. So do you know if the SBA book you showed available in Jamaica? I'm not too sure, but you could probably order it online from Amazon. That SBA book come in pretty handy, especially if you're nothing for SBAs. I have 3 videos up on SBAs that helped a lot of people last year, so you could, and I did 1 extra one, so it can help you this year. So just search Cohen Springer SBA and have a little look at that. Lord, you make the math seem easy until CXC day comes to destroy us. So today in this very same class, we are going to be doing a little past paper question and thing too. So you'll get to see how functions come into play. It is in a half ratio. No, the question is range versus codomain. We're looking at range versus codomain. What is the difference between range versus codomain? Why is the range versus, different than the codomain? Injustice. This meriting business, you need to see. Yes, sir. Codomain is all the numbers that does get output by the function, but range is all the possible numbers. That's well done. You can rephrase that a little bit. You can rephrase that a little bit. Alright, the chat is starting to get a little wild when it have public. Anyhow, he's saying that the codomain is all the numbers that does get output, but the range is all the possible numbers. Like if your codomain is like 8, 6, 4, and 2, the range is the numbers in between the 2 and 8. I feel you know what you're saying. I feel you know what you're saying. The codomain is like in this relationship here, the codomain would be everything I shade inside here. This is the codomain. The range is the actual values. So the codomain is everything in the red. The range is the 2, 4, and 6. Just the 2, 4, 6. Once is a for those who want to be specific, once is not a continuous function, that is. Once is just these set values. So the range is the actual values that come out, the actual outputs, and the codomain is all that's possible. Yes, my pure maths teacher tell me that, such that all numbers are right. Yeah. So hopefully you catch the difference there. So that's just a little tiny thing that could pop in maths, but I don't think I ever see a question asking for range versus codomain, but I mean it there. So we'll just talk about it. But definitely those in ad maths should know about this, and those in pure maths must definitely know about this injective, surjective, all those types of functions. So we're ready to move into functions. Let me see my little notes here. No, we want to identify the different types of relations. Then we'll move into functions. Different types of relations, people. So we can have and I'm sure you all 56 of you all here are experts on types of relations. There are 4 main types you need to know for CXC. 4 types. There are 4 types of relations. So I just draw in my little sets and thing. I'm trying to draw my little ovals here, but you know, problems. What I should have done is draw one and just copy it to the rest. So what I like to do for this, to describe this, is just put a dot. Or maybe 2 dots. So instead of having to figure out any numbers or anything, it's just one thing we want to see. A pattern we want to see happening here. If we have this going like this, and somebody mentioned this, what type of relation is this? How about if that's A? And for B, if I have this situation taking place here, boom, bam, what type of relationship is that? And for C, if I have this type of situation taking place here, what type of relationship is that? It's polygamous, right? If I have this and this and this and this now, and we have this taking place, I see the chat popping in the corner of my eye there. What type of relationship is that? So 1 to 1 is A. And you need to say when you're doing it. A is 1 to 1, B is what, C is what, D is what. So definitely A is 1 to 1. So we know this thing, we know this thing. We didn't sleep during this part in maths class. This is 1 to 1. Because everyone has a distinct one. B is what? Anybody say B? Ariana says B is many to 1. That's correct. B is many to 1. Because we just have one soldier here. And we have 2 ladies here. And we have them joining up here. So we have a kind of 2-timing thing going on there. Many to 1. Many of you all may know about this many to 1 relationship. Come on, we are from the Caribbean. We know about this many to 1. Here we have 1 to many, as people are saying. I mess up one. And the last one is real action. I can identify 2 things leaving the input here, and I can identify in this output 2 things coming to it. So when you're seeing that kind of thing taking place, that's kind of scenario, this is many to many. Why is in the chat if you understand this? This is pretty simple. So you have 1 to 1, many to 1, 1 to many, many to many. Ideal. These are the 4 types of, and you must be able to identify this in your multiple choice. Don't let them free marks in it run away from you in your multiple choice. Right? Now, if you have a situation like this, and you have 1, 2, 3, 4 values here, and 1, 2, 3, 4, 5 values here, and you have a 1 to 1, 1 to 1, 1 to 1, boom, and then this happened here. You do not call this a 1 to 1 because most of them 1 to 1 enough. From the time one of them do stupidness, you have to call him whatever it is. This is what? This is 1 to many. So you have to call this a 1 to many situation. Because he messed up the flow. This last soldier here messed up the flow. Right? It's like if you mess it up one time, if you cheat one time, right? Now let's not go down this line. Now, the next question they usually ask The next question that's usually asked is, so we're trying to see more Caribbean people. So I'm disgusted with your comments on Caribbean people made earlier. Your examples are not family friendly at all. So apologies. The next thing that CXC loves to ask you, very likely in January and May you're going to get asked about this, is which one of these two qualifies as a function. So that brings up the new word, function. If you have paper one to study for tomorrow, free episode. I don't even know how to study for English paper one, but I guess do I do. Studying for English is always be a kind of weird thing for me. But very good. And one-to-one and many-to-one make up the functions. But I introduce a new word. What is a function? Da-da-da-dan. Da-da-da-dan. What makes something a function? That's interesting. What we call a function in maths? I guess I could pull out my little artistic skills here. It's like you have this machine that's run on this conveyor belt here. Tax. And this is your function machine here. Maybe I could put a little chimney there and put some smoke coming out. And put some things here, some things there, some random things here, and in here and out here, right? So what a function does is taking one thing, one value, one unique thing. Let's make this a person, and let's say this person was a 6. We just saying there was a 6, right? And this is like a function or a relationship or some kind of thing, right? But we're using the word function. And this function upgrade them. They come out, bam, a 9. They come out a 9. This function is adding 3. This function is clearly adding 3. Well, we hope it's adding 3 and not multiplying by some fraction or something. But it's adding 3. Horizontal line test. So yeah, man, we come into all these things. So I had a dip. I had to teach myself a year's worth of IT for tomorrow. Good luck with that. When all the members of the domain map onto one member in the image, Jamar is saying, that's not necessarily what makes something a function. Something could be a function and not obey that strictly. The definition for a function is when one input makes only one output. That's it. When you input something into the relationship, into the rule, and you get only one output, that's a function. If you send in the Solia and the Solia send out 2 Solias, that's not a function, that's a cloning machine. And you get some, a function must only take one input, I don't know how to say input. It only takes one of those things and you must only get one output, one image. Yeah, man. I know this exam week, so people will be coming and going. So I know that. I'll hold on yourself for exam week day. So that's it for functions. In a function, each input is only mapped to one output. Yes, yeah, man. I seen that. We come into that. So a function, one input only allowed one output. So a graph we use is something like this. This is a function. Now think about it. The input here is the x-axis. The output here is the y-axis. We're not going into graphs, so don't get frightened if you don't like graphs. This is the input. And if I try to do so, it's only going to map off to one specific output. If this function was squiggly and wiggly, and the line was doing something like this maybe, then this is not a function because it's starting to do ridiculousness. Let me show you what ridiculousness is doing. This input stopped here and made an output, and I can go up here and get another output, and I can go up here and get, that is ridiculous. This is not a function. I don't know what that is. That's an S, but it's not a function. A function, the life is going to be saved. A function is only one output for the input. Think about, let me just ask a quick question. What about this graph? You think this could be a function? Injustice, you're not allowed to answer with your merit in maths and at maths already. Think about this graph here, people. This graph. So we're not going into graphs per se, but we're just taking a little peek at it. This graph, can this be a function? Y's in the chat if you feel it could be a function. N's in the chat if you feel. So people saying yes. If you feel it's not a function, seeing them Y's. Yes, 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 yes. So we've seen Y. So everybody correct. Yeah, there's a function because this is one of the most deadly functions for people in C-Sec maths. This kind of shape here send fear people spine, you know. This is the quadratic function. This is a graph of a quadratic function. That kind of parabola shape there, quadratic function. Now let's show why it is a function. There's something called the vertical line test. Look at that. And you just draw a vertical line. This part of math is ridiculously simple. You just draw a vertical line, and once that line only cut the graph one time, it means it's a function. That's where we get that term, vertical line test. Do you need to know this for C-Sec maths? Yes. You need to know the vertical line test. This could come up in your multiple choice. If you just draw a vertical line and it only cuts the graph one time, you mean each input only has one output. That's a function. Now, why some people may think this is not a function is because this is actually a many-to-one. Yes, like let's say this value was 3 and I got -1, okay? But over here, I'm getting another 3. I'm getting -3 also giving me -1. So I had 3 going to -1. And I had -3 also going to -1. So that's many-to-one. That's many-to-one occurring. So a quadratic graph is a many-to-one function. What does this tell us? It tells us that the top two here are allowed to be functions. These two can be functions. C and D cannot be functions. So anything that's one-to-one is a function. Anything that's many-to-one is a function. One-to-many had a hold up the partner. One-to-many, you can be a function, and you over there, many-to-many, you're not allowed to be functions. Somebody saying, wait, I'm so lost. It is not injective. I thought we were talking about function. Where did this come from? True that. Where did this come from? Jada Jones could help you out for a crack. Wait, it is not injective. Okay. Where are you lost from? These graphs here, you don't need to think. Don't allow yourself to get frightened with the graph if you know your graphs is not your thing and you're still learning about graphs and things. I was just saying that a function, you must have one output going to an in. One input could only make one output. One input here could only make one output. Now, Jamara is saying it has to, basically, you are saying it has to be one-to-one. But that's not true. You could have, not injected, to get people with that major to come. Injustice, slow your roll. I gotta pay an ban just now. You're commenting too much. So, this is a function. Now, if I had this scenario here taking place, that's still a function because I still sent in one input and it gave me one output. This was one input here at a time giving me one output. The one input is giving me one output. It so happens that this input and this input happen to create the same output in the after you check out the scene, you're sending this and you get this. You're sending that and you get the same thing. But it's still a function. It's still only giving me one at a time. But if you see this ridiculousness here starting to occur, like you send in one input and it splits off and gives you two output, that's not a function. You understand? Why is in the chat if you understand that? I want to move on to some functions now. This is all that first half of the class, that 40 minutes we just did, that was all about relations. Now we're going to do a little test on it just now. Should we do the test now? I think we should do the test right now. So let's do the test on relations now, and we'll see. Yeah. So most people explain one more again. Okay, Christian, want me to explain one more time. Christian, specifically, if you can identify where you don't understand, because I'm going to rush through very quickly. Specifically, if you can tell me where you don't understand. We started with the quote. We talked about what makes something a relation. It must have two sets, rules, direction. If the elements are related to each other, so two sets, rule, direction. We talked about relations. You talk about the domain, different names. You could call it input, the x values. The codomain and the range is not necessarily the same thing. We explained the difference. We talked about ordered pairs. That's basically just taking this number and that number and putting it in brackets like this, 1, 3. You know, the pair of the input and the image. Then we identified some rules just by looking at it. By inspecting, we looked at it and figured out some rules. We talked about the difference between range and codomain, so you could go back on that part. Then we talked about the types of relations. The types of relations here. Oh, the graph for the S. Don't worry about the S graph, Christian. Put that S graph, throw that S graph away. I just was being a little wild there. And then we talked about how functions work. One input cannot split in two. It must just give you one output. Then we talked about that crazy S graph that popped up, but this quadratic graphs was where we identified this important thing called the vertical line test that we need to know about. And we are here. We are here having fun in the test. So this test is a simple test. Relations questions are not that rough. When we do the functions test at the end of the class, we'll see how that goes. So, question 1. What injustice? You have to wait till people answer, then answer. What is any other pure math student here? Wait till the CXC students answer. What is another word, or applied math student? What is another word for relations? Then. The vertical line test, you don't understand it? We're going to do it in the test just now, and then I'll explain it again. What is another word for relations? Mapping. Daryl, well done. The answer is mapping. Now, this is part of my magnificent technique that I don't really tell people, but I'm telling everybody here tonight. This is what I use. Even in the live, I'm always doing this. I'm always testing. The number one scientifically proven way to study is to consistently test yourself, continually test yourself. You do not learn, and you can mark this down. You do not learn by just putting stuff in your mind. As crazy as that sounds. You do not know you know something by putting it in your mind. You only know you know it when you try to take it out. And you can only take it out in testing conditions. So something called active recall. Active recall, you need to prove to your brain that you have it and you can recall it. It's better to test yourself than to read over the notes and highlight and all them kind of ridiculousness, which has its own part. You can do that too, but testing yourself is way more efficient. All right, so next question. Next question, people. What is an ordered pair? What is an ordered pair? Give an example. Give an example. So if you want to just give an example of an ordered pair, what do we mean when we say ordered pair? You see, anytime you feel test your filter jump in a hole, you need to test yourself more. So your filter jump in a smaller hole until you stop getting holes, right? Thank God for people one, oh yeah, mapping thing. Bam. So people giving examples here. Always put it in brackets, big man. So 2, 1. That's an example of an ordered pair where we have the input and its image. So we express the input and its image in brackets. Right, cool. Coordinate form, brilliant. We're taking that. How about, I'll draw this diagram here now. 4, 7, 9. I'll put 8, 14 and a little dash there, like I'm being super clever out here. And woo, some questions. 4 is mapped onto, finish that sentence for part A. Part B, what is the rule? What is the rule in that relationship? So people are already pelting out 18, okay. So yes, that's part C. That's 18. Great. Give me the answer for part A now. I didn't see no answers for part A here. It's me or I just not see no answers for part A? Injustice. Well done. 4 is mapped onto 8. 4 is mapped onto 8, right? What is the rule? 2x. Brilliant. Brilliant. So we cooking at Ramco gas day. We can move forward. Okay. Question 4. What is the domain? Which one of those letters there I just put in represent the domain? Which one is the domain? What is the domain, people? X, right? So the domain is X. Okay. Let's be a little more clever now. Oh, no, what number are we on by? Number 5? Number 5, I wonder if anybody remember this. I talk about this just now at the start of the class. 3 conditions to satisfy a relation. Or what are the 3 conditions that make something a relation? Satisfy a relation. Satisfy relations. What are the 3 conditions that make something a relation? Two sets, rule, direction. Well done, Ellen. So you must have 2 sets. You must have 2 sets with something in it. You must have a rule that's connecting them. And the arrow indicates the direction, which one is the input and the output. So the rule was like 2x. So very good. Direction, a directional property. You could write directional property. You must have 2 sets. Must have a rule. Alright, let's go on to number 6. Number 6, we're going to step up the game here. Let's say we have 1, 2, 3. And let's say we have 2, 3, 4, 5, 6. And we are doing this now. Boom, bam, bim. I think I do the same diagram a few seconds ago. I want you to list the set of domain. What's the set of numbers in the domain? Now, we didn't do sets yet in class because we kind of save it. Now we might do that close to the last topic because sets not coming in paper 2. But we'll just learn sets for paper 1. List the, so class people, what is the domain? The domain is 1, 2, 3. So this is how we list it in sets in the curly brackets. Great. What is the codomain? What is the codomain? Here is where it gets a little tricky. What is the codomain? In part B now. What is the range? What is the codomain and what is the range? Dun, 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 dun. So write out which one you're picking when you're saying it. What is the codomain and what is the range? Injustice. This is the first. I know it was I was sensing like you was mixing this up on injustice. I was sensing like you was mixing this up. Yes. No, I didn't really say that this continuous. This discontinuous. That's for injustice. Really and truly, the codomain here is 2, 3, 4, 5, 6. The codomain is everything. Everything listed or created by the function is the codomain. The range is the actual set of values that are accepted. 2, 4, 6. Now I don't want to tie up injustice because you have a point. It could be all the values between 2 and 6 if it's a continuous function. But here it's just a relationship. It's just a relationship. So the range is actually the 2, 4, 6. And the codomain is 2, 3, 4, 5, 6. Just quickly for any pure math students who here, and I don't want to tie them up, you learn something. Very quickly, just a few seconds. If you have something like this, a curve like this, and the domain is x is all real numbers, then in this case, and you stop here, right? You did something like this. This is your curve. Then in this case, your codomain is y is a member of all real numbers as well. But your range, the actual range of values will be from this value, whatever it is, to this value. All the numbers between these two values is a range. So the range is the values that are accepted by the function. Right? I hope that makes sense. Oh, a nice thing to see this, a nice way to see this actually is in a sign graph. If you create this here and you allow your codomain to be all real numbers, the range is actually only between -1 and 1. Even the maths people may know this. The range is only the values between -1 and 1. Alright, that's enough for that. We don't frighten nobody here. We're not doing no pure maths and thing. Next question. 2 more questions and we're going into functions. 2 more quick questions and we're going into functions. This is just to consolidate and make sure we know what we're talking about. After we did all those stuff, we started excel and identify stuff here. So let's see if people can excel and identify stuff here. 5, 9, 11. Can you identify what's the rule that's connecting the output and the input here? The input to the output, what's the rule? Good night, Antonio. Is he seen? Good night, everybody. Good night. (2x minus 1). Christian, well done, buddy. So you're seeing here that it's going up by 2. So it's 2x minus 1. And this was clear. Wait, it's going up by 4, right? And this was going up by 2. So you divide right thing right there. Cool. You're seeing here 2 by 6 is 2 by 3 is 6. Take away 1, and we check it on all. It must work for all. 2. Right, so that's good. So you can say y is equal to 2x minus 1. Oh, that makes sense. One more in this. How about if I had 1, 2, 3, and I have 5, 8, 11, y, x. What's the rule here? What's the rule here? Oh yeah, for those who in the live don't wondering what's going on. Every Tuesday is my online class, but we just decided to do this class. Well, I just decided to do this class public just because we halfway through the syllabus and I'll have some fun with that. Those who want to join the class, this is the number you are texting. Say 87908813. This is the WhatsApp number you are texting to join the class. The class is $200 a month. But bigger than the class right now, we have a crash course that's coming up in December, on the 17th of December. On the 17th of December from 5 to 9. That's 4 hours. But we're not only doing that. That's 17th is a Tuesday. Wednesday we're doing the same thing. Thursday, Friday, Saturday. So that is 4 hours for 5 days. 20 hours non-stop maths, entire syllabus, learning from, just like I'm asking questions here, You'll be learning like that. Questions, 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 answers, questions, answers, questions, answers. Straight through the entire syllabus. That's going to be good. That's called a crash course. So we're going to do a crash course in mathematics, and it's only $200 for 20 hours. One of the people I work with was like, say that's madness, that's a mad price, but that's the price we're doing it at right now. So it's $200 for all that, and you'd be also be joining in the class at that time. So you could message this number if you're interested in that. That's something you do not want to miss, especially for those who do the exam in January, or if you are a precursor. You don't want to wait till quite May to study your mathematics and get a good look at the mathematics. It's just a small price of 200 TT. You pay that and organize yourself, brother. So you just teach applied maths and keep chemistry over that. Killing me bad. Yes, I do. I don't teach applied maths. But I can do applied maths, but I don't teach it. I didn't do applied maths in school. Anyhow, last question before functions. Name the types of relationships I have here. What type is this? A. What type of relationship is this? B. Name the type of relationship here. So you might be hearing some crackling in the background. That is the rain. So that is A, B. C. Is this a function? D. Is this a function? What graphical method can we use to tell if it's a function? So A is one-to-one, correct? No, A is one-to-many, sorry, correct. And B is one-to-one. Great. I didn't tell the formula. Oh, sorry, the formula here was okay, I don't figure it out. 4, you multiply by 4. Nah. How much you going to buy? 3. Right? 3. So you multiply by, and this going to buy 1. So you're going to buy 3. So you multiply by 3x. Let's see, 3 by 1 is 3. So I definitely want to add a little 2 onto that too. So 3x plus 2. Oh yeah, I missed all those comments. I'm seeing them here by Antonio, Selena, Jaden, Daniel, Jamar. IBT, you didn't get this one out. But 3x plus 2, yeah. And right, so what about these answers here? Is this a function? Part C, yes. Part D, yes, Ellen says. Part C is a function. What about part D? Is part D a function? Yes, this is a function because the vertical line test, which is the test we use to check if it's a function, it must cut the graph at only one spot. One spot, one spot, one spot. Anywhere you put that line, one spot. How about D? Is D a function? No, when you use the vertical line test, all of a sudden, these lines overdoing it. This is okay if it doesn't cut, but it can't be cutting at 2 points. That means the input is giving us 2 outputs. That ain't making no sense. That's not a function. These are big no. Alright, so we know all of relations now. Why is in the chat if you understand relations and the person who was having trouble with the vertical line test, that's all. That's all you really need to know about the vertical line test. Nice. So that was all of relations we just do there. Now it's time for functions for the next half of the class. An hour. Well timed. That's a boss, right? Exactly 58 minutes, 59 minutes, going up to the hour there. We're doing it good. We're doing it good. So let's talk a little bit about the notation before we dive into it. Notation. Notation. What does notation mean? Anybody knows what notation means? What does thing mean? By the way, notation here just means that's like naming. That's like these terms and symbols they use. So like if we talk about sets and I say set notation, that just means the terms and symbols and signs that we use in sets. The way we write things, like I live with that. Diamond Chambers, we live in that. The way we write things. So fx, this here means f, we say this like f of x or function of x. It means we're going on f. we're going to use the function. We're going to function on x. We're going to function on x, right? Yeah, we're going to function on x. The function, whatever the function is, we want to do it to x. So that is what f of x means. Another way you might see this in exam is f dot dot x and then the power arrow, like that. And then they write wherever it is, 2x plus 1, wherever they're feeling to write on the day, 2x squared plus 1 f. Yeah, we gotta keep it, yeah, gotta make sure, you know. So f of x, this means the same thing if you see it in the exam, those things, so never do no semi, should never do no colon and thing, I don't know what that means. It just means the same thing. They could use what they want, don't get frightened. Now let's go into substitution. That's enough annotation for now. We can learn as we go along. Substitution. F of x is equal to 3x plus 1. We did a lot of algebra in this class. If we have f of 3, what's the answer there? Well, by the way, see the answer in the chat. This just means so you just wrote functions in there. How we know on functions? Oh, relations and functions is taught together. So there's teaching relation, they'll teach you relations, and then boom, they'll teach you functions. So that's why you have to learn like relations. 3 by 3, this is how you want to write this, right? So this is 9 plus 1 is 10. Well done, all the 10 people. 10 out of 10 out of 10. What the hell? What's this? Okay. How about if we have g of x, because you know we love in them letters in maths. They love to use f, g, and h. G of x is equal to, let me say, well, you're feeling by a little x squared plus 1 and then divided by 2. Yeah, that's what I'm good. What is g of negative 5 then? What is g of negative 5? Yeah. Now, all I'm doing tonight is relations and functions, and this is the one class that I'm making public. There are 25 other classes that we did before. We did computation and enumeration, we did matrices, we did all of construction, we did all of consumer arithmetic, all of algebra, and all of trigonometry. That is about between 45 and 50% of the math syllabus there. Answer is 13, that's correct. So if you want to join the class, the number was given before, plus 1, 2. So this is 25 plus 1 over 2. This is 26 over 2. This is 13. So this is the part of maths people, you know, I like this. And this is why I think maths. This is when you think maths, you think this, right? You really think, you know, start drawing and all kind of thing. So this should be simple. How about, well, you think it's time to learn inverse, boy? I feel it's time to learn inverse. Why isn't the chat if they're ready to learn about inverse? Let me learn inverse, yes? Inverse. Inverse. Remember the machine. Remember the beautiful machine that I drew. Where the thing, boy? I know, right, the function. The function, it take this person who was a 6, send them in, and boom bam bing, they come out a 9, right? Now the inverse is just going the opposite way. If this function is x plus 3, because it clearly is here, we see like it could be an x plus 3 function, could be something else, but x plus 3, we're going with x plus 3. It can't do the inverse if the function is quadratic diamond. And I'll come to that just now. So x plus 3, what is the inverse of this function? Well, to go from 9 to 6, I'll have to take away 3. So the inverse here has to be x take away 3. So this is f, and the symbol for this notation is f. I put -1 as the superscript there, right? Over, so f -1, and then you come back down brackets s. So do more fraction function. Yeah, we're not only doing easy thing, we're coming down to some tough stuff now. But we're breaking it down bite size so nobody could say they get lost along the way. Or if you're getting lost along the way, you can quickly find back yourself. So let's say we had this function now. F of x is equal to 2x plus 1. And I want to find the inverse of f of x. I want to find the inverse of that. You could just watch this and figure it out. But CXCs give you 2 marks for this, so you have to do a method. But you could watch this and figure it out. We took a number, we multiplied it by 2, and we add 1. Injustice done pop the answer there. We multiplied it by 2 and we add 1. So the first thing to go backwards is we need to take away that 1 that we just add back. X take away 1, and we'll end up right about here. So what's the next step? We have to divide that answer that we just get by 2. Let me show you what I mean. If we break up this function into 2 parts, you're multiplying the number by 2, and then you're adding 1. That's the function. It's like 2. This is what inside the machine here. So if you want to go backwards, machine. If you want to go backwards, you're going to have to take away the 1. Boom. Then you'll have to, this is multiply. So you have to divide by 2. Boom. That makes sense? Why is in the chat if you understand that? If you machine. Now if you do 2a, so what? Ask questions. If something missing, let me see if anybody have a question. So if you want to have this in CXC and collect your marks, I advise that you do everything. How you do it over? Yeah, let me explain that little concept situation there again. Okay, sure. F of x is equal to 2x plus 1. Remember when we had these things? 1, 2, 3. And we had, if we're doing 2x plus 1, 2 by 1 plus 3, that's 3. 2 by 2, 5, 7. So this is that. 2x plus 1. You can see that, right? 2 by 1 plus 1 is 3. That's like it going there. 1, right? 2 by 1 plus 1, and the answer is 3. So this is the next thing we could write here is f of x instead of writing capital Y. And we write x here. These are the x values and those are the f of x values. But we want to go backwards. We want to do f inverse. That's the whole point of this next section here. F inverse. To go backwards, we will have to think about it, right? Think about it. We multiply by 2. When we multiply by 2, always get, by the way, 2. We multiply by 2 and we get 2. And then we add on 1 and we get 3. So if I want to go backwards, I need to take away 1 from this, get back the 2, and then divide the 2 to get back the 1. So the inverse of this function here means I need to take away 1 from this new x value. This output, this x here is actually the output now because I'm going backwards, and then divide by 2. How to tell the domain and the range. We did that already. You just had to look back when the video upload. You have any bearings video? So I have some high quality bearings video, and I have maybe about 5 or 6 hours of bearings video on this class, explaining. The last video we do last week was a whole class just going through bearings, explaining the last bit of bearings again for the class. So you can feel free to join the class. Once again, I'll put the number one more time: 1-868-790-8813. WhatsApp this number, join the class, 200 a month, and you'll qualify for the you'll qualify for the crash course that we are having in December from the 17th to the 21st. 21st? Yeah. I still understand nothing in bearings. Don't worry. Crash course coming up. Where would the class be? The class is online. So it'll be just like this. Alright. Let's look at how we're supposed to do this for CXC. First thing first, we write the function f of x equals 2x plus 1. Then there are 3 steps, people. A lot of things in CXC I teach using 3 steps. Somehow 3 steps sticks very quickly in people's minds. So I'll just say 3 steps, and people is remember the steps and that'll be good, right? So start a step. First step, let y equal f of x. You are always going to do these 3 steps. You are always going to write these 3 steps. The payment methods, when you WhatsApp the number, she'll talk to you about the payment methods. The payment methods, you can use anything. You can use except Western Union. You can use bank deposits, bank transfers, online bank transfer, PayPal. Well, I say anything. I don't really take like you coming by my house and paying me and I really tell her that. But you could use any of those methods there. So let y is equal, you're letting y be, and I also have a class of pure maths too. So those who inside the pure maths and want some action in the pure maths, we have a nice class going on for pure maths. Online class. Okay, so let y equal f of x. I'm going to do that. Y is equal to 2x plus 1. You all understand what happened there? This is f of x, and I'm saying I don't want to write f of x all the time. It's too big and nasty. I don't want to write f of x all the time. I'm going to let y be equal to f of x. So y now. That's nice. I love y, I love x. So y is equal to 2x plus 1. I got it that. The next step. One time we reach the second step, we're nearly done. The second step is interchange variables. What does it mean to interchange variables? In brackets here I'll put swap. Because people is understanding the word swap. Yeah, well done Selena, well done, well done, well done, well done. Antonio, ting. Interchanging variables mean you'll do this. Instead of writing y, anywhere you see y, put x, and anywhere you see x, put y. Follow the instructions and your life in order. And now we're on to the final step. Just like that. Make, and people don't write it in the chat already. Make y the subject of the formula. What does it mean to make something the subject of the formula? All it means is we want y to sit down by himself. Y to relax by himself. Christian, we come into that, my brother. We come into that. Stay focused. We come into that. We come into composite functions. We're doing inverse functions right now. So this is what we're going to do. We are going to bring this one across because we want y to stay by himself in front of the equal sign. So if I'm bringing that one across the equal sign, it turns negative, right? I'm subtracting 1 from both sides. Some people understand it like that. Subtract 1 from both sides and this one will go bye-bye and will end up over here. Next up, I want to get rid of this 2. Now, I couldn't get rid of that 2 first. Those of y'all who playing the hanky-panky in algebra right now and trying to get rid of the 2 first thing, you can't do that. You get rid of the 1, then you bring across the 2. So it's going to be y is the, sorry, I should leave it the other way so you can see it. Y is x minus 1 over 2. And if you remember, this is what we were saying when we was doing it mentally. You take away the 1 and then you divide by 2. So after you write that, all you need to do now is come and write this. F inverse of x is equal to x minus 1 over 2. Therefore, so very quickly now, show me this here. You can send me into the group if you want for the class people. You can send the answers into the group. I'll take a look at your working. I spelled substitution wrong at some point in time. Alright, thanks. Where I spell it? Inverse subs t. Oh gosh. That's real bad boy. Substitution. Earlier, this is a maths class. Not an English class. Boom, boom, bang, bang. Okay, so guys, I want you all to find the inverse of this function. F of x is equal to, let me do an easy one again now. 4x minus 3. I don't have an maths class. I used to have an maths class, but I pulled off on the maths class for now. That's getting drained. So we have pure maths unit 1 and CSEC maths class. Very good, Antonio. Very good, Donna. Yeah, Kristen, I'll come into that. So let me just write it first. Let me just do quickly that y equal f of x. Y is equal to 4x minus 3. Always write this, interchange variables. Don't write shortcut like me, Write all the whole long thing. Then make y the subject of the formula. So in the end, you're going to end up with x plus 3 and then you divide by 4. Same thing like just now, right? F inverse of x is equal to x plus 3 divided by 4. Why is in the chat if you understand that? No problems at all there. But what will happen now? I don't know how I end up on that page. That was like a easier. Let's do a medium level one for CXE. If I have x squared minus 3, find the inverse of that. Find the inverse of x squared minus 3. So what is f inverse here? This is a little tougher. By the way, these kind of questions already, exact numbers and things, similar numbers already come for CSEC maths. These same squared things. I was looking at them very recently. As recently as yesterday. Wait. Square root of x plus 3. Square root of x plus 3. Square root of x plus 3. Now I hope you all mean what I think you all mean. Donna said it a little better. X plus 3 and square root of that. When you say square root of x plus 3, it could mean square root of x plus 3. But it's actually the square root going over the whole thing. So let's just do it very quickly and see what happens here. Pay attention because this is where people lose marks easy. Let y equal f of x. You know, we like to start like that. We want to interchange up the variables. So I'm going to put x here and I'm going to put y squared here. I want to make y the subject of the formula now. So I'm going to bring across the 3 and people are seeing that x plus 3 is equal to y squared. Now a mistake we make here, we know when you have y squared and you're trying to make y squared the subject of the formula here. We know that we're doing some square root simi-dimi. Make sure that you're putting the square root over everybody on this side like that. Like that. So you find the square root of both sides. Square root here, square root there. And you'll end up with this scenario taking place here. So therefore, f inverse of x is equal to x plus 3 and the square root of that. You understand? The square root of everything. Yeah, so you use brackets like Shania, Antonio, and Aaron just did there. That makes it look a little more sweet. Now, time for the hard boys. Time to bring in the big boys. So these also come for CXE. And when these come, people is be kind of out of it. A lot of people doesn't be able to complete these kind of questions. These kind of questions are stressful. So f inverse of x now, how do we do this one? The problem that you will soon see if you're writing this now, and if you're not no pure maths and maths student who are accustomed to this kind of madness, the problem that you will encounter is there are 2 x's all of the time before we was dealing with 1x. 1x there, you know, 1x here. You know that square is just 1x in a spot. But here we have 2 x's in different spots. And this is a lesson in life. When you have more x's, things get harder. Things get harder. Try and have less x's, you know, don't overdo it. So x plus 3 over x minus 1. How are we going to do this one, boys? So let me reach where everybody should be at. The first two steps, we're not supposed to stick for the first two steps. It should be like let y equal f of x, and you'll get y is equal to x plus 3 over x minus 2. Brilliant. That's sweet. Y is equal to x plus 3 over x minus 2. Nice. I'm getting you no marks for that as a teacher yet. If you interchange the variables, I may not get no marks for that either. Interchange the variables. Yeah, you might get something for that. Interchanging the variables, x here. Now we have two y's here all of a sudden. And we know the next step we need to make y, you all see that, right, my handwriting? Make y the subject of the formula. So Danny is saying y is equal to 3 plus 2x over x minus 2. We'll see if she's correct, right? Memorize that answer there. Somebody say x minus 3, but put it equal to y and cross multiply, yes? Good night, Kiana. Why would we find, we don't break up? Why would we find x, we don't break up? Train across. See x in x here for me. Not one thing. These kind of questions. Yeah, so this is the big boys here. Daryl is saying is x minus 1. He has a little difference than Danny. These are the terrible inverse questions, and you know something, they like to bring these types of questions. These come, if they do it inverse, they generally bring in this kind of x in 2 spot question, x in 2 spot. So how are we making something the subject of the formula if it's in 2 spots? We're going to make y the subject of the formula in 2 spots. Last time, when it was here, we just bring across the 3, but we can't really bring across anything because it's not up in a numerator and a denominator here. So I'm going to go on a new page and show you how to do this very quickly. X is equal to y plus 3, and on the other end we have y minus 2. So if we want to find the inverse, if we want to find f inverse, we want to make y the subject of the formula. Our first step is to multiply across by the y minus 2. So now we end up with y plus 3. We go in places. We is going places with this. So we still see y in 2 areas there. Our aim is to make y the subject of the formula, right? So we need to, you know what? We need to break down this wall. This wall is stopping us from getting to the y. So let's break down that wall. That's the next step. So that's using the distributive law, right? Not so? So this is x by y is xy, and x by negative 2 is negative 2x is equal to y plus 3. So now we are seeing the y's clearly. There are no walls stopping us. There's a y here and a y here. Our next step should be to get the y's on one side. Get those y's on one side because we want it to be the subject of the formula. Hey, getting the y on one side would mean taking this and bringing it over here like that. Subtracting y because it's add y here right now. And I'll send him across there because I don't like him. He doesn't have a y in him. So I'm going to put 3 plus 2x here. So anybody who got 3 plus 2x and then numerator, going down the right road. Going down the right road. So we have all the y's on one side now. And people putting factorization in the chat. That's correct. We want to factorize. How do we do this? You all remember this from algebra? When you have a term here and there's commonalities taking place, you take them and put them at the start of the bracket. So y by what will give me back this concoction here? X. Y by x is, now the reason we taking out the y is because we want the y by himself. So we took out the y. Subtract. Now this is a little weird. There's a y here. What number to put there, boy? We're going to put 1. Because y by negative 1 is negative y. So that works for us. We are at the end now, we are at the finish line here. Because we could just put y here now and put 3 plus 2x and get rid of this whole brackets that's multiplying by the y by just putting it under there like that. Y is in the chat if you understand that. Y is in the chat if you understand that one. So this is something you can have some fun with. So let me give you an next question so you can have some more fun with this one. Because remember I said Knowing something in maths is not putting it in, it's taking it out. The number one technique for studying and revising. This is what students used to do at get at the top of medical school, to get at the top of engineering, excessively testing themselves. There are students that don't take notes. They are listening to the lecturer. All they do is create questions. As he's talking, as they are going through their lecture notes, create questions. And that's it. After, when they're revising for exam, they're not even looking at the notes again. All they are doing is watching their questions. The strongest method, I keep saying this, I'll keep saying this every time. I'm saying this for 2 years now. The strongest method to learn something is to keep testing yourself. Keep testing yourself. Sometimes they say, you have to say something 7 times. When you say something 7 times, then people start to accept it. Well, I will not say the 77 times, and then people start to understand the importance of testing yourself regularly. And people don't like to test themselves because they don't like to get things wrong. But getting things wrong is part of testing yourself. Y is equal to 3 plus 2x over x minus 1. Alright, let's try this one. F of x is equal to x plus 3 over... That's the same thing I write last time, right? Let me make it 2. Let me make it x plus 5. And let's put a 2 here and see what happens. Let's put a naughty little 2 there. X. Let me make both of them positive. I know I could play with negative numbers. Right. Size real loud, yes. Yeah, it have a volume button in the Daniel. You can organize yourself. You can organize yourself. One more like that, please. So we want to find the inverse of this. Remember, the first 2 steps follow the same principle. When you reach to the line where you say make y the subject of the formula, you have to bring up that denominator, expand, bring across the y, factorize, do your thing. Add maths classes? Nope. But I'm going to do add maths crash courses for CSEC. You can bet your bottom dollar you're coming through with them crash courses for CSEC. Now, for those who worry and say, so going paid right through now, boy. No. I am still going to be doing lives, staying up right for those of you who experienced that experience this year. I am still going to be up right through. I just get very happy around exam time. I'm still going to be spending my whole night doing lots of subject areas: maths, chemistry, biology, physics, add maths, pure maths, unit 1, technical drawing, IT, no business subjects, no language subjects, but basically everything else for exams. We're gonna have some fun in 2020. 2020 is our year to kill them off. Yeah, it's very clear based on the operations that CXC does not like me, but we will still mash them up. Right now, CXE is in my DMs. I shouldn't say in my DMs, but they are in my supervisor's DMs. That matter is still under investigation. As late as this afternoon, I was talking to somebody about that. But we do business. We're going to help the Caribbean students. We're going to help the Caribbean students and legally help the Caribbean students as well. Yeah, my family. I don't neglect my family. In fact, why I'm doing it online, I used to do classes straight up to. So you've seen some answers popping in now. I need to stop talking. Let's see what the people are saying. Let y equal f of x. So I'm going to speed through this question. Put y is equal to x plus 5, 2x plus 1. I don't neglect my family. Interchange and variables. I used to be at private lessons right through all up to 9 o'clock, 10 o'clock. I'm now finishing my classes for the day, every day, until I decided, you know what, let's just stick to online. So I just have a few public classes now. X plus 5, 2x plus 1, y, we interchanging. I'm making no mistakes when I'm talking and writing where things can happen. Now we want to make y the subject of the formula. Make y the s of f. Now don't go and write no SFF in your exam. I mean, if you're feeling lazy and you want to play around with them marks and things, you can feel free to write SFS. But write subject of the formula. Then x. So the first step is to multiply by the denominator there, because we see it in terms of steps now. And your brain getting accustomed to this activity now. Then we know, because you do it already, we know that there's some kind of multiplication scenario taking place here. X by 2y is 2xy, and x by 1 is x. Now if you have 2yx, that's okay as well, that's also correct. It's just that in math we like to go in alphabetical order now. You know, we do things in order, except handwriting. So 2xy plus x is equal to y plus 5. Now the next step was identifying that we have two y's there and we want them on one side. So I'm leaving this 2xy and bringing across this y there. This is now 5 minus x because this x comes across there and switches sign. Now I can factorize out the x, because y into this is y by 2x will give me back that. Alright, so the x is money making thing, they don't care about us. It may seem so, because based on the rumors and insider information I'm hearing, let me just, and you all should know some of these figures. There's about 80,000 people that do maths every year, CXC maths. So if 39%, 40% passing previously, and my activity is driving that percentage up to 50% passing, that's 10% of 80,000 students money lost for CXC when they repeat in 2, 3, 4, 5, 6 times. So you could put one and one together and get your answer there. So y is equal to 5 minus x. 2x minus 1 will end up here. So we want to bring this down after you have factorized out the y. We bring that down. So we have 5 minus x, so 1x. Those who have 1x, that's okay. And you have 2x minus 1 underneath. Yeah, just imagine. So we on to the last part of the class now. The last part of the class is dealing with functions. I may or may not be able to give you a little active recall testing that I do, but those who are in my class, obviously the next assignment is going to be on all of these, and I expect to see very high grades in the next assignment. In the 25th assignment, we had 300 or 400%. Daryl did make the 100% this wrongs, brother. But we had 300 or 400%, which was amazing. Let me call all these names quickly. Well done, Keziah, seeing you working here. We had Jamar, Sajda, Michelle, and Natalie. 4 people get 100%. That's crazy in the last assignment. And the assignments doesn't be easy, although this was a 1-pager compared to the normal 4-page. You're just giving somebody else a chance. You're sounding like me when I make a mistake in that. Do you have lessons that I could attend? It's an online class. It's an online class. Once again, for those who just joined, this is the number you use. That's not right with the highlighter, Cohen. This is the number you use, 1-868-790-8813. You WhatsApp this number. Where's the WhatsApp symbol? WhatsApp that number. What is that there? W? I don't know what's the WhatsApp symbol. You WhatsApp that number and you get through. The cost is 200 TT a month. We have online payment methods like PayPal and stuff like that, or you can use bank transfers, bank deposit, whatever float your boat, use that. We have students from Guyana, Jamaica, Barbados, almost every Caribbean territory I've had students from already. So jump in, that is be real vibes, especially again chance. I have 2 tutors that work along with me and they go through the assignments and send me back your marks and everything, and we continually try to improve the class to keep the quality at the top. Make mistakes in the composite and on the final. Alright, so let's go into the composite functions. I hope nobody tired. We're on the last last quarter of the class here, just about 20 more minutes again to go, people. Composite functions. What we need to do here is, remember we was using a machine, like a f of x machine, you all remember that? This machine from before was adding 3. Let's introduce another machine. Let's call it the g of x machine. And let's say this machine now is machine. Let's say this machine is, I don't know, what to say this one doing, boy? This one is multiplying the number by 2 and adding 1. Since that was equal. Multiply the number by 2 and add 1. Let's see, I want to join your class next year. Blessings, jump through next year. I was tired since class start. 2x plus 1. That's g of x, and f of x is x plus 3. So what I'm talking about here, boy? Composite, let me make sure I spell this with correct. Composite, right? So composite functions is like joining it up. What would happen if I was to send the number 1 through here? What's going to happen is going to add, and I'm going to get 4. What will happen if I send the number 1 through here? It's going to multiply by 2 and add 1, I'm going to get 3. Now what would happen if I didn't do that? And I'm like, you know what? Let's join these machines up like this. So I'm going to say that the output of f of x becomes instantly the input of g of x. And let's send the 1 through again. So 1 is going to add 3. I'm going to get 4. And I'm using the same 4 and sending it in here. So this is 2 by 4 is 8. I hope you're with me. Yeah, I'm just taking the 4 and putting it where I'm seeing x here. 2 by 4 is 8. Add 1, that's 9. So my output is 9. This is a composite function. Composite, you know, composite words, 2 words come together, 2 functions come together, composite function. Now there's some little tricks. What? With the next live, my next class is going to still be on functions. It's going to be 1 more functions class. 1 or 2 more functions class. We're going to be looking at some tougher, 1 or 2 or 3 more function class actually. You're going to be looking at some more tougher things than functions. Quadratic functions, things that come in section 2. Quadratic functions, stuff like that. Linear programming. Excuse me, and all the syllabus has to offer on functions. So there's some technicalities in functions. For example, the function we just did is that we did f of x. We did f of x, and then we take f of x and put it in g of x. So the way we write that in maths is g, g f of x. G f of x. G f of x is not the same as f g of x unless they are inversed to each other, unless they are inverted functions with each other. Unless g is the inverse of f, this will never happen. So f g of x is not the same as g f of x. F g of x means start off with the g of x first, so send the 1 through g of x first, and then this output will go through the f of x. So order is important when you're writing these. The one that is closest to the x is the function that we are applying on the x first. Alright, let's check it out with a little question here. Let's say f of x was 3x plus 1. And let's say g of x was x squared. If we are asked to find an expression for gf, some of you all see gf there, you know, x, gf of x. Find an expression for gf of x. It means the function that is closest to the x, the f function, must go into the g. How are we going to do that? Ace, scroll up and do my question. Scroll up and do his question. Bro, I scroll in here for a very long time and I see no question, so you're going to have to write back that question. I know right, he does see the questions. What question? Oh, nothing. So scroll up and do my question. I am scrolling and there is no question. I don't know if you're talking about the first question. Thank God I finished school and away from this. That's not helping Ronnie. Ronnie, that's not. You have to scroll real far, Brethren. I ain't scrolling that far. So yeah, right back that question. G f of x. G f of x. What do we do for g f of x? Yeah, I like to think of it like taking the whole of f of x mentally and putting it in g of x. So, okay, what I do mentally is like write x, the g of x in my mind. I want to put a plus 1 here, people. I want to put a plus 2 here, people. I want to take away 2 here, people, just so you see clearly what's happening. Daniela and that was correct and stuff, right? But I'm switching it to take away 2. So, and I'm not going to simplify. I just want to show you what's happening here. So in my mind, I'm writing g of x, x squared minus 2. But anywhere there's an x here must get replaced by what? F of x, because I'm putting f of x into g of x. So instead of writing x squared, I'm going to take these things. I'm going to take my... I put 3 here. All you understand what happening? So I'm taking f of x and putting it in g of x. Anywhere I see x in g of x, I'm putting f of x. And now I can square out this and simplify and think, but who going and go through all of that? Not me. How about f g of x? It means it's the other way around. I'm going to take g of x and put that in f of x. So I'm writing f of x in my mind now. But not x going. You need to put in what g of x is. X squared minus 2 plus 1. That makes sense. Now I can simplify this to an extent because you know it's just a 2. 3x squared minus 5. Bam! That is fg of x. Why is in the chat if you understand that? I just want a year vacation. Oh my god. Pure Maths video soon, sir. I have a whole Pure Maths class in a brother. Or Shen, sorry, or sister. I have a whole Pure Maths class. Just call the number and free up yourself. WhatsApp the number actually. So good. We nearly done earlier. We nearly done. Let's try one with 2 and see if people will get this. If f of x is equal to 2x plus 5 and g of x is equal to 2x plus 1 over x. Find the value of, find an expression for g f of x. Yeah, I write any number here, 18687908813. This is the number for the class admin. You WhatsApp this number and you can join our Pure Maths class. It happens usually on Mondays or Fridays. This week we do the class on Fridays. Could explain a little slower, sir? I can. Tell me which area is giving problems. Which topic, which part, which part is it? It's killing you. Yeah, this class, this live video, I'll let this stay public. I will let it stay public. 2x plus 5x plus 1. Anybody give any answers yet? So it's recording and will be on your YouTube. Yes. Any answers yet? No answers yet, people? Yeah, the answers, people. 2 by 2. Yeah, that's correct. We can simplify that, you know. Darren, I'm not too sure about your answer, then, brother. Not too sure. I think you forget to multiply by 2, you know. Cheryl, yours looking sweet, you know. Cheryl, that looking on point. Hear me, Cheryl. Cherry. Cherry Rose. Cherry. I don't know why I see a L there. Rose. That looking good. Iran. Iran, what going on there, boy? You need to explain that one to me. Yeah, I think you leave only two there. Hadia, you could. I would know the answer a couple months ago. So you're taking f of x and putting it in g of x. So once again, like write g of x in your mind here. And then we need to replace them x's, yo. So it's not two x's, and I'll put it in red so you'll see what's happening. 2x plus 5. This is from the f. This is from the f of x plus 1 all over, and I'm putting 2x plus 5 here again. That makes sense? Now, when you reach here, you probably get you get the lion's share of your marks there already. But you want to simplify, especially if this is say to simplify. So all I'm doing is multiplying using the distributive law in the brackets there. Plus 1, 2x plus 5. And I feel like a 4x plus 10. Is that 4 or 5? 4x plus 10. Did you say 5x plus 10? No, 4x plus 10. Right, so 4x plus 11, 2x plus 5. Right, so we add the 10 and the 1. Why isn't the chart if not making sense? Not making sense. You take the f of x and put it in here. Now the reason we're doing that step is because the f of x, the f is closest to the x. Alright, I think I labored in the vineyard enough there with that composite. There are this is all of basic functions. All of basic functions. There are three things I left out. That's in basic functions. And I will talk about them now. 1. Conditions for inverse. 2. The horizontal line test. I talked about the vertical line test. Do you know there's a horizontal line test? What is that? The horizontal line test. And 3. Stuff like this. F inverse of x. Because I see this coming quite a few times. The concept of this is coming. And 4. If you see this, what does that mean? F squared x. So that's about it. That's the three things. This is inverse. So let's just talk about this briefly. Now, other than these two, I don't really see the first two coming that much. Like the knowing that and not knowing that would make a difference really. But you know now, how to be complete within the whole syllabus. So the conditions for inverse goes back to what makes a function. Remember, a function can be 1-to-1 or many-to-1. Those who were here from the very beginning, right? A function can be 1-to-1 or many-to-1. In other words, a function must have one thing giving out one thing. Like this. Or you can have, where's this one by? iPad by. Or you can have this situation, one thing giving out one thing, and this going to that one as well, but it still means this one input created one output. This one input created one output. It did not split like this. Anytime you split like this, there's not a function. You're starting to go one to many and not functions. So to be able to find the inverse of a function, you must be this. You must also be something they call onto. Or surjective for those who in pure maths. You must be onto. Boss man, deal with functions in depth. I got Cape Pure exam tomorrow. Functions. The thing is, I started functions in my pure maths class as well, and we went through a lot of functions. It would really help. So join my pure maths class, brother. Join my pure maths class. Okay. I don't want to lose track of what I'm talking about. We're talking about conditions for inverse. Why something will not be an inverse. Why you'll be able to find the inverse of something. Think about it. If this is 1 to 1 and the inverse means go backwards. Go backwards. That's what the inverse means. If I go backwards here, it's still 1 to 1 and 1 to 1 is a function. If I try it with this guy over here, this is a function because one input is creating one line, you know? One input is creating one line. That's cool. We accepting that. If I try to go backwards, all of a sudden, this becomes the input and it's splitting in two, and that's a big no-no. You can't have that. That's not a function. So this solely cannot be a function. Cannot be there's no inverse for that. You can't work out the inverse function from many to one. And that's why people are saying, just now pure maths people are saying, try to find the inverse of a quadratic. You don't do the inverse of quadratics because you'll get a plus and minus. You'll get, this was, if you think about the inverse, and we'll talk a little bit more about this next week, the inverse switches it makes a reflection in the line y is equal to x. We'll talk about this next week. I know the graphs and thing is kind of frightening some people right now. We're not into the graphs land yet. But yeah, so the conditions for inverse is that it must be 1 to 1, and you can just memorize this. It must also be onto. So in other words, it must be, and you can use this word if you're feeling hyper, surjective. It must be surjective. You must get you must use all the outputs, all the inputs, right? Nice about it there. Nice about it there for that. What's the next thing we need to talk about? The horizontal line test is what we use to test if something can have an inverse. It's what we use to test to see if something is 1 to 1. If I use the horizontal line test here, it will fail because I will get 2 solutions. 2 solutions mean you fail the horizontal line test. Let's try our next thing. If I have him like, if I have that and I have a straight line like this and I try the horizontal line test, imagine these lines are horizontal, people. It doesn't cut the line twice with these lines here. So you're not failing the horizontal line test. So it means that this can have an inverse, and it also means that this is 1 to 1. So the horizontal line test is used to check if it's 1 to 1. And finally, the last thing that we need to talk about tonight is why does this happen? Why is it when we use the composite functions of a function with its inverse and we compose those two together like that? Why do we get x over there? Why is x the answer? It's very simple. Think back at the machines that we were using to explain this scenario. I think it was plus 3, and that was f of x. And we started off at 1. F of x, so if we use f of x, we add 3, we get 4. So f of 1 is 4. Or, yeah, f of 1 is equal to 4. Now, if I did f inverse of 4, I will get back 1. Because f inverse means to go the opposite way. F inverse would be take away 3. So take away 3 from 4, I'll get 1. Now if I decide to play hyper and do it like this, f inverse of f of x, and I compose them, I will essentially be going forward, then backward. So I will end back up on x. Think about it. I will find the function of x, I'll get the 4, and then when I do the inverse, I'll come back to my original 1. So if I actually try to work out stuff like this, I will get back the x. I will get back the x like this, right? You tempted me there, Leron, you tempted me. So f inverse of f of x is equal to x. Or it could be written the other way, right? F of f inverse of x is equal to x. You can spend some time experimenting on that. I will give questions on that in the worksheet, but most of the questions will be on the stuff we did earlier in class today. There is one more thing I want to do. I want to do some little quick questioning with you all. Actually, I think I did the questioning when I did some questions in between, so I think we can call that George for today. The questions will come. Yes, I do add maths, Jonathan. I do add maths. But I don't do add maths online again. Add maths online will come in next year. But I will be doing crash courses coming down to the May exam, so stay tuned to the channel, and I will be shooting out free videos ever so now and then on topics, and I have lots of free videos, including a good bit of add maths as well that you can look at. I assume you do physics as well. Yes, I do physics. I will be doing a physics crash course. So how often do you go online? In the maths class, I go online every week, Tuesdays, 7 to 9. Very strict with that. And so don't take too long to send the worksheets. Alright, bro. The worksheets will come in tomorrow. My credit card full, I'm going to donate like crazy next year. So why don't just join the class? Join the pure maths class, Lauren. Join the pure maths class. We have a group and everything, and you know, the pure maths class is vibes. And coming down to the exam, it's gonna be crucial and critical. Aaron Scott, I want to do keep next year, but maths is my weakness. Okay. Jojo, yes. I have anxiety, yes. SMH. Alright people, so this is the basics in functions here. This video is a pretty nice video. I think so. It's 2 hours. People who learn in functions online for CXC could always come back to this video and watch out through the whole thing and get a nice basic understanding of relations and functions. Once again, I just want to reiterate the crash course. The crash course people, bring this back up. The crash course is on the 17th. Imagine that I color the whole thing to right and white of December. It starts on the 17th of December. It goes on for 4 hours every day of past papers, and the videos will be there for you to watch over and over and over and over. Right? So join this crash course. There'll be private videos, a private crash course online going on. 4 hours and 5 days, because we go in 5 days. We go in Tuesday, Wednesday, Thursday, Friday, Saturday. 5 days. That's 20 complete hours of crash coursing for January and May exams. So make sure and jump in on that, and I'll just leave my number right here. This is not my number, but the class admin for 868. Forget the number, 7908813. WhatsApp that number. Why are you trying to draw the WhatsApp thing all the time? WhatsApp that number and jump in the dance. Aaron Scott, take it down now. Can you re-upload the multiple choice videos? Right now, there's some technicalities with multiple choice videos. I have to make sure that it's not coming for exam, and that is not questions that could come back in CXC exam, and it really had a way for me to make you know, that unless CXC decide to partner with me, CXC, you know, if you're in some partnership or something. So I can't really do multiple choice until I show. Well, I'll still try to do multiple choice, but it had to be stuff that I made or stuff that I could vet in a certain way to make sure it's not coming back exactly like that exact question not coming back. CXC and some real foolishness with that. To be honest, they had some real foolishness with that, because, but that's a whole next topic that I want to talk about right now. Where is the worksheet? Where is the worksheet coming out? The worksheet is coming out in the online class. So I have an online classroom. Those who in the online class get the worksheet, and it's corrected and sent back to them before the next class, along with their marks and where they went wrong and tips and stuff like that. So they're mad because you're making us do better than making any sense. So do keep your maths for us, please. I already have the Learn, message me on Instagram. I'm gonna tell you what to do. Message me on Instagram. So I go on there for the 9 people. Feel free to join the pure maths class, the maths class, and the crash course for maths. Until next time, we shall link. I'm really trying to get some more videos out this week. Maybe some pure maths videos on. I wanted to do it pure maths, or I think I wanted to do function self. But until the next time, lessons, my people. Do not become weary in doing good. Keep doing good. Smile at somebody today. Tomorrow, shake somebody's hand, help somebody understand something. I don't know. Do something kind, and we may help each other to make it out here for the people.